This is the middle school math man with a video here on multi-step equations. So before we get started with some problems, I want to just talk about the acronym DCVAM. So this is just, a way of thinking as you're working through these problems. So again, just like GEMDAS, DCVAM is just an acronym, and each letter means a different thing. You can see them here on the screen. D stands for distribute. So we're going to have some parentheses, we'll have some stuff inside the parentheses, and again, we need to distribute the number right outside the parentheses to everything inside of it. C stands for combining like terms. So for example, 2x plus 3x plus 1. My like terms there are the 2x and the 3x, that would be 5x plus 1. V stands for variable to one side of the equation. So we'll have some problems where there are variables on both sides. Normally we want our variables on the left, so I'm going to work to get all my variables on the left during that step. A stands for add or subtract. So at this point we're probably down to a two-step equation. We're going to have to add or subtract the constant, get it to the other side, and then M stands for multiply or divide to go ahead and get that variable by itself. So we're going to start out with a fairly straightforward multi-step equation problem. Again, DCVAM. So first we need to figure out if there's anything to distribute. There are no parentheses, so I'm not going to distribute anything. I'm going to move on to combining like terms. So at this point, I should look on the left side of the equals and the right side of the equals. There's nothing on the left side of the equals that I can combine. However, if we look on the right side, we do have some things we can combine. 4x and this negative 2x are like terms. So 4x minus 2x is 2x. And then I'm just going to rewrite everything else that I'm not going to use. It's very important with multi-step equations to write everything down, to stay organized, and just do your operations right below so you can follow your steps. Alright, we're done with combining like terms. Next, v is variable to one side of the equation. So again, normally we like our variables on the left. So I'm going to take this 2x, and it's positive 2x, so I'm going to subtract 2x from both sides. So those cancel. I'm left with negative 15 minus 5x equals, there's nothing over that on that side anymore, so it's going to be equal to 0. So my variable's now on one side. A stands for add or subtract. So I'm going to get rid of this minus 15 by adding 15 to both sides. So those cancel. I'm left with negative 5x equals 15. M stands for multiply or divide. So this is negative 5 times x. So the opposite of multiplication is division. So I need to divide both sides by negative 5. Those cancel. I'm left with x equals negative 3. This is important. Notice how here I had negative 5x, so I divided by negative 5. If I divided by positive 5 there, I would get negative x. I don't want negative x, I just want positive 1x. So now, the way to check, you're going to take the negative 3, sorry about that, take the negative 3, the answer that you got, and you're going to plug it in for every single x that you see up top. And then you're going to rework the problem out, and then you should get the same answer on the left side of the equals as you do on the right side of the equals. So both sides have to equal each other. That's how you check your answers. Moving on to the second problem. We have parentheses on both sides. So again, DCVAM. D stands for distribute. So I'm going to distribute 7 times p is 7p. 7 times 3 is positive 21. Then I'm going to rewrite everything I don't use. On the right side, 5 times p, I need to distribute the 5 to that stuff. So that's 5p minus 10, and then I have that minus 3p over there. So I don't have any more parentheses. I got rid of the d in distribute, the d in DCVAM. C stands for combine like terms. So look on the left side. Look for like terms. We have 21 and 9. So I need to combine those like terms. So I get 7p plus 30 equals So now looking on the right side, we have some p's that we can combine. Those are my like terms. So 5p minus 3p is 2p, and then we still have that minus 10. So we don't have any more like terms on each side, so we're going to move on to v in DCVAM, which stands for variable to one side. Normally I want it on the left, so this is a positive 2p, so I'm going to subtract 2p. Those cancel, so I'm left with 5p plus 30 equals negative 10. Be careful, the sign in front always goes with the numbers. That's negative 10. So my variable's on one side now. So A stands for add or subtract. So here it says plus 30, 5p plus 30, so the opposite of that is minus 30. What I do to one side, I have to do the other. So those cancel, and I'm left with 5p equals negative 40. Almost done. M in DCVAM stands for multiply or divide. So this is 5 times p, opposite of times, or multiply is divide. So my final answer is p equals negative 8. And again, if you plug negative 8 in for all the p's, you should get the same number on both sides of the equal sign. So these last two problems, these are our kind of like special cases, if you want to call them. So you're going to see as I work through this problem, something funny is going to happen. So let's go ahead. We're still going to use the same exact steps. I didn't write out DCVAM on the previous problem because I didn't have any room. But here I got a little bit of room. So first thing, distribute. So I get 2x plus 4 equals 4x plus 1 minus 2x. Alright, so I got rid of the parentheses. C stands for combine like terms. So look on the left side of the equals. Do you see any like terms? No, there's 2x and 4. Those are not like terms. Look on the right side. We do have some like terms. 4x and negative 2x. So I'm not touching anything on the left side, so I'm just going to rewrite it. On the right, 4x minus 2x is positive 2x, and I still have that plus 1. So we don't have any more like terms that we need to combine. V stands for variable to one side of the equation. Again, I'm going to take this positive 2x, which is on the right side, and get it over to the left side. And hopefully you're noticing something here. When I do that, those cancel. So now look on the left side. I have 2x minus 2x on the left side also. Those cancel. That's 0. So I'm left with 4 equals 1. So when I did this step here, the variables kind of just like canceled each other out. 2x minus 2x is 0, so they're not there anymore. And I get 4 equals 1. Obviously, that doesn't make any sense. This would be a no solution problem. The answer to this problem would be no solution. There's not one single number that you could plug in for x that would give you, the same solution on each side of the equal sign. You could plug in any single number. You could plug in 2, you could plug in 1,000,000, you could plug in negative 10 for x. There's no number you would plug in where you could get the same number on both sides of the equal sign. So that is no solution when the variables drop out and then the numbers are different. Last problem in this video, we are going to do the same exact steps again. DCVAM. We have to distribute, so 2x plus 8 equals 4x plus 3 minus 2x plus 5. I didn't do anything on the right side, so I just rewrote it. C, combine like terms. So look on the left. Are there any like terms? No, there are not. So on the right, there are like terms. I'm going to rewrite the left side. On the right, we have two sets of like terms. We have the 4x and the negative 2x. That's going to give us 2x when we combine them. We also have positive 3 and positive 5. So 3 plus 5 is going to be positive 8. You're probably already noticing that we have the same exact thing on both sides of the equal sign. That's interesting. So you might be able to tell from this step here that we have infinite solutions, but if we keep going, v stands for variable to one side. So I need to get my variable to the left, so I'm going to subtract 2x from both sides. Now it should be very obvious, because the variables drop out. They cancel each other out, and I'm left with 8 equals 8. There's nothing else I can do. Like 8 equals 8 tells us there are infinite solutions. And that means that every single number you plug into the x's in the original problem, it'll give you, the same number on both sides of the equal sign. So every single number is a solution to this equation. So that is the three types of problems we can have. We can either have one solution, like the first two problems we did, x equals -3, p equals -8. So that means that's the only solution to the equations. Or we can have no solution, where no number you plug in will be a solution to the equation. Or you can have infinite solutions. Every single number you plug in to the equation will be a solution.